So recently I've been interested more and more in the history of transportation. And well, if I show you this, maybe it doesn't sound like it's a transportation for you, but I like to show really from start how we've improved our way to move and behave. So we've been working on two legs and faster, but quickly we've mechanized how we transport ourselves and amplifying our mechanical and biological functions. But then soon we started to use fossil fuels. So we start to put an engine, we can transport more people, but it's requiring more energy. And soon enough, we're using trains. And trains are amazing because they do two things. The first is that they reduce the friction by running on a rail. And the second, they reduce the resistance to air because the first wagon is pushing the air, so the next wagons don't have to push that air. So that's why you achieve more efficiency. And actually, maybe I don't know if you heard of those trains, but the Maglev trains are reducing these two factors by a lot, by having no friction because they're levitating thanks to magnetic force. And the second is that they will be running inside vacuum tunnels. So we expect those trains to run at as fast as 2,500 kilometers per hour. So really, really fast. But if you look at the progression, we are going from using your muscle, and it's a lot of effort, to having a lot of energy coming from the outside. And yeah, we want to go faster, we need more energy. So I've been pondering if there could be alternative ways, because we're talking about lots about green energy, wind power, solar power, and many of the technologies that are applied for transportation are still very marginal experimentations. If you think about the power of the rail, it really changed how continents were conquered. For example, this is the growth of the railway system in the US. And I like to think that we are at similar stages for many of the renewable powered vehicles. And so I've been thinking, playing just about 3.5 weeks ago when I was talking to the TEDx organizers. So they knew about my other technology, which I presented afterwards, but I wanted to present a demo to explain the physics of the, not this robot, but the next one I will show. And maybe you know this vehicle. So this is called a land boat. You have wheels and your wind power. So the question is, how would land boat would look like if it was like a train? And so it's here. So if you had a train but it was wind powered, how would it look like? Maybe something like this. Whoop. So I wish I could demo it to you right now, but there are some small mistakes and some small mechanical problems. There's some more friction in some of the joints, so I cannot demo it to you at full scale with the propellers here, and I'm really sorry for that. But instead, I'm going to show you a machine that we tested 4 days ago in Hong Kong, where I live, which was double the size. One jump. So what I like about this machine is not that it's a wind-powered machine, but what I love the most is that the only power source in this machine is this. So the machine is 6 meters long, so it's bigger than most of your guys' car, but it's powered with this tiny motor. That's the only thing that needs to power, is just to control the position of the front wheel of this guy. So I like the idea that we could control bigger and bigger things with less and less energy. The basic observation is for example, when you're trying to park your car, maybe you noticed when you're trying to park a car, you have to turn your wheel, and it's a lot of energy you need to put. But if you're running on the highway, just a pinch on your wheel, and you could be going off the road. So the question is, can we use less and less energy by building bigger and heavier and faster vehicles? So that's what I want to keep exploring in the next few weeks. I'll make some space. Getting tidy up. Okay, so reason why I came to build this machine is because of the BP oil spill. So what's the connection? The BP oil spill is actually touched an area or a coastline that's longer than the whole coastline of Estonia. Imagine if the entire coastline of your country was suddenly covered with oil. This is what happened in the US. And so thousands of men and women were deployed to clean up the oil spill, and that was very inefficient because they cleaned only 3% of the oil that was on the surface. And they also exposed their health, and they could only work during the day, and so it was a very, very bad system. So my initial idea was, could we use the wind power that is moving the oil? So I was studying the oil and how it's moving, and it's moving simply with the wind, with the waves and the currents. So the idea was, could we sail upwind and intercept the oil that is drifting down the wind? So the oil is going down and we'll be going up the wind. So that's the basic idea. But I tried this with a regular sailboat, and it's proven to be really difficult, because as soon as you add payload, like I just did on this machine, then you start to lose control over the trajectory, and it's becoming heavier. And so this boat that you're seeing is a little bit different, because the center board is shifted at the back, and the rudder is very much at the front. So like this, the rudder could act as a lever on the center board that's acting as a center of rotation, if you will. But while I was developing those successive prototypes, I invented the shape-shifting hull. So this is the shape-shifting hull. So that's the second demo. So this boat doesn't have a center board or a rudder. What's happening is that the whole boat changes shape. So what's happening is that instead of turning a small rudder at the back here, you control the whole boat shape. So imagine if you had a train, but you could control the whole trajectory by changing the entire shape of the vehicle. And so it has numerous advantages. Oh, okay, so this is the boat sailing. So you can see that you have a trajectory control that's much superior to a regular sailboat. So you could make very steep turn, and it works better in low speed and also high speed, although we haven't tested very high speed. And so you see it's very gracious, kind of like a little fish would swim. And okay, so the main characteristics of this is that the first, you can, thanks for the lighting, you can control better trajectory. And also, just like I was going to show with this boat, if it was working better, is that when you are turning, you'll be basically catching the wind from different sides. So say the wind is coming from the direction of the stage, and so I'm in this position here. So I would have wind blowing in this direction, but I would also have the wind blowing in this direction. So I'll be catching essentially wind from both sides of the vehicle, which is completely different from any boat that or land boat that you've ever seen before. So that's one of the main advantages. And the other one is that the shape-shifting hull, because it's flexible, most boats, when you're going quite fast, you start to heat the wave a lot. This one actually has a tendency to kind of bounce on the waves. So a lot of the energy that's not damaging or slowing down the boat is absorbed in the structure. So the question is, can we make the same? Can we power the locomotive, kind of first boat, and then pull lots of stuff behind? And that would have many interesting advantages, because imagine if in each of the modules you could put a different experiment. So for example, if I'm studying oil spill, I would have an oil sensor to define where the boat should be going. And in the next module, I could have, say, a fish sensor, so I could see how many fishes are dying from the oil. Or I could have just regular temperature and acidity sensor to see the interaction between the oil and the environment, the chemistry. And now, what if each of these... Oh, OK, so this is an actual boat that we've built. So this is it's 3 meter long, and it's pulling 25 meters in the Rotterdam port. So it's absorbing oil that's just coming from the tanker just next to it. And yeah, so that technology works as we pull it. But the question is, could we actually power each of the modules? So we don't know yet. We've started to build boats like this, so just with 2 modules. And this is just 2 weeks ago. So we keep on building new machines all the time. And so this is how it looked like if you were on a shape-shifting boat with multiple modules. It's kind of dizzying because the whole boat would kind of move in front of you and behind you. Okay, so right now we are using just a simple remote control to understand better the mechanics. And the next for us is to use, we've been using Arduino on bigger machines, but the next stage for us is also to use Android phone. So this boat already is already optimized so you could use an Android phone. So, for example, I would take my phone as an example. So you would be basically putting the boat inside the water, and you would take your mobile phone, and there you go. You could trace GPS and control your boat from a web browser. So that's what we're building next as well, is to build a web interface so you could control remotely your phone. So you could just connect to your phones. So as long as you're in a 3G range, you could, kind of call your boat and say, hey, go on the left, or go and inspect that place. So right now, to do ocean science, you need research vessels, and they are very expensive typically. They are millions of dollars worth boats. They're very expensive. There's only one commercial surface vessel that does ocean science, and it's called the wave glider. And think of it as a surfboard that has a pair of wings underwater. The surfboard goes up and down, and it pulls on the rope. And as it pulls on the rope, it makes the wing move, and the wing eventually will kind of pull the surfboard. Those machines are amazing, and they can stay very long in the sea, but they cost $250,000 for a piece. And so only the big oceanographic center can buy it. Our dream is to... Oh, the graphics has disappeared. Oh no, this is our dream. Our dream has disappeared. Okay, well, the illustration is a planet, and it has many of the boats, like this one, with multiple modules. And so the point is that we're trying to make this boat, as you can see, to have the same capacity as the wave glider. So the wave glider that can carry 50 kilograms for a couple of months at the time at sea. And we're trying to build this, the same capacity boat, but for less, or about $1,000 US, so hundreds of times cheaper. We're trying to do this in the next 2 years. And so that would mean that instead of having one surface vessels, you could operate hundreds of them, which means that instead of having one line of data like this, then you could have an entire map of the ocean. So that's the dream. I wish I could show the picture. So just the same way I just showed you the colonization of the US with the railway, sometimes I get to be romantic, and I like to think we're doing kind of the same, like going to explore the oceans. And if you think about this, this is a very old technique. It's even older than the rail. So I have a good belief that we can use this very ancestral technique to go again and explore again the oceans with similar techniques. And also this is that doing these experiments, we are slowly realizing that one of the main problems of autonomy is energy. When you're in the sea, you are subject to tremendous energy, waves, wind, sun, and most of the time they are your enemies. But what about we invent technologies like those one that require very little energy to be powered and control very large amounts of instrumentation or materials to go and clean up the oceans? Okay, so apart from the technology, which is cool, actually maybe technology is the easiest part of this. Long time ago, when somebody like me had an idea, he was working backstage in a theater like this, or probably in his garage, and this is changing. With the communication technology, it's very easy to connect to other people in universities, or now with internet, you can create a movement quite easily. And with technology, if it's becoming so pervasive, then you can invent something and then other people can fork it. But technically, it's made difficult by patents, because if you have an idea and you patent it, then people cannot really use it. So all these technologies I'm showing to you today, they're all open source. So the idea is that anybody can use, modify, and distribute the technology for free. Actually, if you like this, you can start your own business with it. I'm fine with it. Seriously. The idea is that the ocean is big, and we really care about resolving these problems. And the ocean is big enough so we could all develop these technologies and make a living out of this. The only obligations that people who use this technology would need to just give us a bit of credit, just say, okay, just like in science, the person who invented this first, and most importantly, to share back with the community. So whoever uses and improves this technology has to document it and share it back with the community. So that's the license, the open hardware license. So this is the beautiful planet that we've inherited. And this is pretty much what we've done of it. We've colonized the Earth with the land and with beautiful railways amazing technologies, but we've pretty much, we are ruining the land. And so the question is, are we going to continue using the same type of technologies for the ocean to explore the oceans? Because more and more we need to go and access the ocean resource. So if we keep using the same technologies, well, this is likely the picture that we'll have of the ocean in a short amount of time. So if you keep using those big diesel engines, those big research vessels to go and do ocean research, we're going to destroy the ocean as the same way we've destroyed the land. So what I'm trying to say here is that we need not only to change the technology, but also the way we work together. I've been voluntarily exposing myself to a lot of these ocean issues in these last years. So the oil spill, so I used to work at MIT, working on the BP oil spill, and I moved to New Orleans where I lived for 2 years. So I worked for 2 years on the BP oil spill, working on the cleanup effort. And I was last February in Hawaii to collect plastic samples. My family is living close to Fukushima in Niigata in Japan, so I will go back again for the 3rd time this September and spend 3 weeks to measure radioactivity underwater. Acidification, I think you will tell me more about it than I can tell you about this, because I heard that the Baltic Sea, this is my first time in Estonia, so this is my first time in the Baltic Sea, and I'm interested if you can inform me about what I should see. And overfishing. So beyond this huge challenge I just showed you, which we need to address, the ocean is really a place that is really strategic for all these factors. It's the future for our food. Most of our human population lives in big cities, and most of the big cities are by the ocean. We're eating more and more fish. This is most of the energy of the ocean is untapped. Actually, there's so much potential in the ocean for the wave, from the tides, and the transportation, the communication. Most of our communication actually are going by underwater optical cables that are running under the sea. Most of the warfare today, a lot of the warfare is happening either in space, on the ocean, underwater. And yes, and so it's not only because we like the ocean or because I love the ocean that I care for this, and I think these technologies are important. It's because all these technologies are going to be strategic in our future. And so this is the image that was missing, by the way. So this is the idea, is that I hope that we can develop open source, open technologies to explore and protect the oceans together. Thank you very much.